So the learning objective in this video is to calculate arc lengths, angles, and areas of sectors of a circle. And basically this topic is it really just breaks down into thinking about, how we, in previous video, how we talked about kind of breaking down shapes. This is basically the same principle. So if you have a circle, if I can get one out, such as this, such as this, and you want to calculate, say, a portion of the circumference, which would be kind of an arc length, right? So if you want to calculate, this arc here, you want to ask, to calculate that arc length, you'd think about what portion of the circumference is that. And how would you do that? Well, we can think about, say, how the angle, if we kind of go to the center and draw out the angle of this kind of sector here, we think about what portion of that is of kind of the total angle, right? So if this was, say, 30 degrees, we think about, hey, what kind of portion is this of 360? So, 30 over 360, that's kind of, if we think about kind of the portion or kind of the slice of the circle we'll take it. So clearly, if we've got, say, 90 degrees, that would be clearly a quarter circle, right? Which would, then the arc length here would be a quarter of the circumference. And it's just basically that principle. We just think about what fraction of the circle is it, and the fraction of the circle will be kind of the angle here divided by 360, and then we just times it by, say, the circumference, or if we're looking for the area, by the by the area. So if we're asking, say, if this is 30 degrees, and there's a radius of, say, 4, and we're asking to calculate this arc length in red, we'd say, so the length is equal to, so the portion of the circle it is, times by the circumference. So 30 over 360 times by the circumference, which is 2 pi r times 4. So that's equal to, so 30 divided by 360 times by 8 pi, which if we just get our calculator out, we can just do that. That comes out to 2/3 pi, and that's our answer there. And if we were asking about, say, the area of this sector, this thing here, is equal to, then, so again, the portion, or the fraction, sorry, will be the same, and then we just times by the area of the circle, which is pi r squared, so pi times 4 squared. So that's just 16 pi, times 30 over 360, which would be 4 over 3 pi. So that's how we do something like that. And sometimes you kind of have to reverse engineer this. They might tell you what the area is, and then kind of, if they say that the area of this thing here is, say, I don't know, 8 by 3 pi. And then they ask you to find what the angle is. And of course the radius stays 4. So you say area of sector, so, you might say, let the angle be theta. And you say area of sector then is equal to theta by 360 times by pi r squared, so 16 pi, which is then equal to 8 over 3 pi. And if we just rearrange and solve, theta is equal to 8 times by 360 divided by 3 times 16, which is, it comes up to 60 degrees. And that's how we'd kind of go in the opposite direction. So I've just got a few questions which involves this kind of thinking. So the diagram shows a sector of the circle, center O. The radius of the circle is 13 degrees. The angle of the sector is 150 degrees. Calculate the area of the sector and give your answer correct to 3 significant figures. This is literally the same as before. So if we think about a full circle, right? We'd have something looking like this, and the circumference is still 13, of course. And we think about the fraction kind of this is of the full circle, and clearly the fraction is 150 over 360, right? So the area will equal 150 divided by 360 times by the area of the circle, which is 13, so pi r squared, which is pi times 13 squared. If we put this into our calculator, 150 divided by 360 times by pi times 13 squared, which comes out to 221.2204827 . And again, to 3 significant figures, right? So 221, which is to 3SF. And then we need our units, 3SF. There we go. We've got another question as well. This is a bit trickier. So the angle ABC is the arc of the center. So ABC is an arc of the circle center O with radius 80 meters. So ABC, this is the arc, as you can see. AC is a chord on the circle, so this is the chord, and angle AOC is 35 degrees. Calculate the area of the shaded region. Give your answer correct to 3 singular figures. So, go ahead, pause the video, think about how you might do this. This is very similar to the kind of the composite stuff we were talking about before, where you have to kind of look for 2 shapes of areas that you do know and kind of work from there. So please do go ahead, pause the video, see what might work here. So in this case, if you find the kind of the area of the whole sector, which is O, A, B, C, if you look at that area, and then you can take away the area of this triangle in here, O, A, C, and then you're left with the shaded area. Let me just, so if we have in red, O, A, B, C, and in say green, we take away this, or maybe an orange even, we take away the triangle to get the area. So we'd say kind of area of sector OABC is equal to, well, if we think about what portion of this sector is of the full circle, it's 35 over 360 times by the area, which is pi times by 80 squared, pi r squared. We can kind of leave it in this form if we like, or maybe simplify it as a multiple of pi. So 80 squared times by 35 divided by 360. Okay, that's not a nice number, so, is it? Sorry. Times 35. Yeah, it comes out to 5,600, 5,600 by 9 pi, which isn't a nice number, but it's not a bad fraction. And then we have to do area of triangle. Oh, I don't have to write triangle twice. OAC is equal to, okay, so pause the video and try to figure out the area of the triangle if you haven't, did pause back there. We covered this just a few videos ago, so please do go ahead, pause the video, give it a go. So the area here, we just kind of, as the application of that sine rule we were talking about, calculating the area of any circle. It's a half AB sine C, so half times 80 times sine 35. And this we know won't really simplify too nicely because sine 35 isn't a nice number. And how do I know that? It's because if you remember your values for sine, 30, 45, sorry, 0, 30, 45, 60, and 90 are kind of the nice numbers. This sine 35 isn't a nice number. So, you can leave it in this form, or maybe you can do 40 times 80, and then sine 35, which would make sense. So 80 times 40, which is 3,200 sine 35. And then now we have to look at the area we want. So area of shaded is equal to this big area minus that small area, so smaller area, 5,600 by 9 pi minus 3,200 sine 35. And we shouldn't expect a nice answer because it says to 3 singular figures anyway. So if we do this on my calculator, 5,600 pi by 9 minus 3,200 sine 35, which comes out to 119.324 da. And again, to 3 singular figures, just 119. And then what are our units? So this is in meters, so meters squared to 3 SF. And there you go, that's our answer. Yeah, so in questions like this, you have to think about, as usual, sometimes in composite shapes, you either add areas together, or in this case, you're taking away areas. So it's just important to think about, what areas can I guess what are the nice areas, what areas in this big shape can I calculate quite easily, and then start taking away. So this is actually a fairly common type of question where you have to kind of calculate the area of the sector and then take away the area of the triangle. I haven't included one kind of in this case necessarily, but sometimes you have, say, I can actually just whip up a question like this pretty quickly. Say we've got a sector of a triangle such as this, not triangle, I mean a circle, and say it was, I don't know, 47 degrees here, and it's 14 centimeters wide, and the radius is 14 centimeters. This is O, A, B, C, and then you also calculate the perimeter of this shape. So the way you do this is, what's important to remember is not only do you have to calculate the arc length, but then you have to add the 14 and the 14, which is kind of a common mistake sometimes students make. So you have something like this, and you can say arc length, which you can say is ABC, is equal to 47 by 360 times 2 pi r times 2 pi times 14, and then therefore perimeter is equal to 14 plus this thing here. It's times 28 pi, which comes out to so if I do it to 3SF, that's 39.484266, and then to 3SF, 39.53SF centimeters. So, these types of questions are also fairly common, where you have to kind of find the area of the perimeter of this whole shape. What's important is not to just find the the arc length, but then to add these 14 back in, which is a common mistake students make. But yeah, hopefully this video all made sense. Everything in this video just comes down to the principle of thinking about what fraction of the circle it is, the sector we're concerned with, and that will just be the kind of the angle here divided by 360, which is literally the key principle, and from there it kind of everything just follows. But yeah, hopefully that all